this portion of this video, I'm basically going to be talking about the wish list, and basically with the wish list comes with the shortcomings of our project and what we would have wanted to implement. So basically, I'm very happy with what we've accomplished. We've created a powerful backend API with Docker for database container management and other stuff of that nature. If you look over here, we have a Docker container that handles our database and our backend and all sorts of that nature. But basically, I would have wanted to see three more things. I would have wanted a more sophisticated natural language processing system. I would have possibly wanted a more durable architecture for the backend instead of just using Python, doing some sort of microservices with message queues, and I will dive in more into that. And also, instead of just creating a web application, create a Chrome extension. So I'm going to go first with the first issue. I'm going to go with a more sophisticated natural language processing platform. So basically, why? Why should we make a more sophisticated platform? Basically, if we look over here at frequency, as you can see on the right portion of my text editor, we have frequency, we have LUN, we have some basic. These are quite impressive natural language processing algorithms, but they're not that sophisticated. And I would have wanted to see more sophistication. Basically, we're summarizing web documents, and in machine learning terms, that is a unsupervised learning. We would use unsupervised learning models. So I would have possibly wanted to use some neural networks. It would have been cool to use more sophisticated machine learning algorithms. Use algorithms like TextRank, for example, to identify important sentences and important topics within a given document, and then create separate paragraph summarizations for each topic. So we would have a richer multi-paragraph summarization of a given document instead of just having one summarization. For the second portion, the architecture of backend, if you look at our code base, if you look at the right, this is mostly a Python dominated backend code, and our backend API is powered by Python 100%. But if you look at the ML tools folder of our backend folder, you'll see some non-Python code in here. You'll see some Haskell code. Actually, I wrote a linear regression algorithm in Haskell, and I also wrote a lazy streaming code base in Haskell, originally meant for this project. Originally, I would have been down to create a more sophisticated backend platform. And what I mean by that is, on top of having Python as a backend API, using message queues, whether it be Kafka, Apache Kafka, RabbitMQ or ZeroMQ, using those as message queues being a way a main backend API would talk to a microservice. We would have wanted to implement microservices in different languages. We were looking at Scala and Haskell as the two programming languages our platform would be working on. And basically, we were thinking of having microservices because our more sophisticated machine learning algorithms would use the programming language that best fits its task. And performance reasons also vary between programming languages. For example, this is another project that I've had, and I've used Apache Kafka before on that project, and basically it was the same kind of a platform that I would have wanted to implement with the senior project. You have the main backend API basically in this diagram as the interface group, and the microservices would have been in the compute group, and I would have used something like Kafka or RabbitMQ as a way to communicate, let the backend API communicate with the microservices and so forth. Possibly in this project, not use Kafka, lean more on RabbitMQ because I would have wanted more complex routing message patterns, whereas Kafka is a very simple pub-sub system. Haskell would have been perfect because if you look at the code base here, Haskell shines in computationally heavy programs that don't have much I/O, and also in matrix operations. So it would have shined a lot on a lot of machine learning algorithms. Also here at CERN, I'm actually using Scala as my one of my projects here. And Scala is a great way to take advantage of the Java virtual machine, but basically get the performance of the Java virtual machine, but also implement some functional programming aspects and also get away from the verbosity of Java and basically be more productive than you can get with Java. So that's why I would have wanted to use Scala and have Scala's microservices. And then last but not least, I would have wanted to see a Chrome extension and not just a web application, because I believe a Chrome extension is more natural to the user. If you wanted to summarize a document, it would have been more natural as a user to use a Chrome extension rather than using a web application and do context switching, which would have been uh, very, very, it's very unnatural. A Chrome extension would have felt more natural if you were browsing a web document and you wanted to summarize it right there on the spot. You wouldn't have to switch tabs. It would have been really easy. So basically, those are our wish list and shortcomings for this project. And I sure do hope that we would have had more time to implement them.